My name is Nathan Hamill. I am the AppSec track chair for Black Hat, so enjoy.
Thank you all for coming. This is, as Nathan said, the web apps track. This is the HTML top 10 threats, and you'll be presented by Shreeraj Shah.
Thank you. Okay, good morning and welcome to the talk. I'm going to cover some of the HTML5 attack surface and top 10 threats today. As you can see, my title is Stealth Attack and Silent Exploits. You're going to see why HTML5 looks a little stealth in nature with XHR and so on. So that's something which we are going to cover today. Before going, brief introduction of mine. I'm a founder and director of a company called BlueInfi. We focus on application security, do consulting, training, research, and so on. In past work with these companies, founded a company called NetSquare, Foundstone, Chase, IBM, and so on. My interest is web security research, so spend a lot of time in doing research on new techniques, new development, and so on. Enjoy writing some tools, scripts, and so on. And then share this knowledge in form of published articles, tools, advisories, presented at various different conferences, and perform trainings. And these are some of the books written by me: Web 2.0 Security, Hacking Web Services, and Web Hacking. I do blog, and this is my Twitter address as well. I do tweet as well. So today agenda very simple. We'll start with HTML5 basics, just to touch the attack surface. Then we'll focus on top 10 attack vectors, and then we conclude and have some questions. Okay, so HTML5 vectors. If you go out and search around some of the news items, these are some interesting news items you will be able to see. 2012, a lot of predictions are coming up with HTML5 as it adapts. A lot of opportunity for hijacking the browsers out there with HTML5. Interesting research was done by ENISA. They have taken HTML5 has various different specifications. So they have taken 13 specs and tried to do a threat modeling on it and found 51 possible security threats. So HTML5 and security threats are on the rise, and you have new opportunities which are coming up with HTML5 and so on. Now, briefly looking at the HTML evolution, pretty much from 91 we have started with HTML, and essentially it runs in a browser in something called thin model. We wanted to have a thin application and all the processing on the server. So that's the model with which HTML started, browser started. But if you look at the evolution reaching at the 2005 point, where we have extensive use of AJAX, DOM, and XHR, that changed the whole perception. So our browser started to move from thin to thick. And pretty much in 2009, when you have HTML5 specification coming up, HTML5, the browser is no longer, I would say, a thin client. It's a very thick client which we are looking at. It's like you can compare HTML5 specs with a small mini operating system running in your browser. We'll see that why I'm saying this. So HTML5 has arrived, new surface, new architecture, new defense. And technically looking at HTML5, it is nothing but the HTML plus CSS plus JS which we used to run in a browser. But the one major change which we have here is HTML5 tags are not just the plain tags. They are binded with APIs. For example, if you have video API, then the video tag, and then you have some APIs like a pause, play, and so on. So various different new APIs are injected, and various different new tags are added to HTML specs. So one of the biggest questions which we have when you are doing the threat modeling or analysis of the application is what is running where. You want to figure out which component is running in browser, which component is running on a server, and so on. So traditionally looking at the application, we had a presentation layer which is coming in a browser and executing the stuff. That is not the case now. With HTML5 and pretty much with the Web 2.0 in the AJAX era, what we have is in the browser, we have business logic, presentation layer, and data access layer running there. So pretty much from the attacker standpoint, we get a larger attack surface, opportunities to do reverse engineering, and so on. Now, on these particular area, which is covering various different technologies there are 4 stack of technologies which is right now in the browser. One is definitely a Flash, with a Flash plugin, AMF, Flag, Storage, XML, and so on. The second is Silverlight, WCF, .NET, and so on. The third stack is HTML5, which is web storage, webSQL, XHR, DOM, JS, and so on. So what have happened in the last 2 years is essentially Silverlight and Flash is fading out and HTML5 is taking over in the browser application space. And importantly, the browsers running in a mobile, which is Android, iPhone, or so on, they are capable of running HTML5 applications. So you don't have to code various different applications and various different libraries. You can actually write an application in HTML5 which opens it on your mobile device, on your desktop device, and so on. So this is a very important change which we are looking at from the architecture standpoint, which components are running where, that's important. HTML5 in a nutshell, if you look at, there is a flower of new specs which you can see over here, like we have storage, we have cache, which resides in a browser, we have video, canvas, geolocation API, drag and drop, webSQL database, a thin database running in a browser, webworkers, the threads which we have in the browser, and so on. So pretty much there are HTML5 is not just a one spec, it is a combination of various different specs out there, and on top of it, pretty much Chrome, Firefox, Safari, and IE has started implementing HTML5, and pretty much lots of specs are already implemented in HTML in all our browsers which we are using at this point. So this is a HTML5 in a nutshell. Now, modern browser architecture, if you look at the current browser, be it IE, be it Chrome, or so on, it has clearly 4 different layers which we have here. This is very important when we try to understand the threat surface or attack surface over here. So one is definitely security is baked into the browser with the set of policies. So what you have is policies like sandbox, SOP, that is a same origin policy. CORS has a new policy which has implemented in the browser, which is a cross-origin resource sharing policy and content security policy. So this is a policy which gives a baseline for the end user, which is loading a page or HTML page in your browser. Network access layer, that's the where things are changed. We have 2 different specs which are added in HTML5, which change the whole perception of our networking. So what we have is a WebSocket. You can have from the browser using JavaScript. You can open a socket, duplex socket to TCP socket to anywhere, and then XHR level 2 calls. So we were having XHR level 1. Now with the new spec, we have XHR level 2. So that's a network and access layer for the browser. The process and logic layer, we have a JavaScript. We have a very empowered DOM. That's a DOM 4 specs which we are running right now in the browser. The most important part is we have threads in the browser. So now browser, when you load a page, you can fire 5 or 7 threads at the background. They are doing the processing and then using a post message mechanism by which you can access the threads which are running at the background. So the threads are known as web workers, which is pretty much implemented in all the browsers, and you can write your own web worker which is running in the background as such. With this, what we have is these 4 little buckets you are seeing. One is we have a webSQL or IndexedDB. So you can have a database which is running in your browser. You can have a cache. You can say for offline browsing on HTML5, you can cache the pages on the browser. You have a file system. So pretty much you can create for your domain on the browser, you can create the whole file system. So there is a file system API which allows you to create any kind of file on the system and on the fly you can use. And a 4th is a storage. You can have a local storage and a session storage part of your browser. So pretty much looking at this, you can't say that this is a thin client. This is a thick operating system which is running as a browser in our mini operating system which is running in the browser. And pretty much we are into back to the future, or pretty much I would say a thick is a new thin for us. So that is how the new browsers are lined up. And on top of you have a presentation layer where HTML5 and CSS, which runs on all mobile devices, which runs on all browsers and so on, residing. And the plugins are there, which is Silverlight and Flash. Pretty much these components will fade out in the next 2 or 3 years, I would say, and HTML5 will survive as a core architecture. So this is how the architecture would look like. Now, looking at the threat model, on the presentation, we have several different vectors which are emerging: CORS vector, UI redressing, DOM attacks, APIs. And on the business logic front also, we have web messaging and XHR, storage, file and cache, webSQL and IndexedDB and web workers. So this is a kind of a threat model which we are looking at. Now, let me show you a sample application over here. So over here we have this application, which is, say, for example, a simple web store, which is written in HTML5. So when you start the page and open in a Chrome has something called developer tools. If you start that, there is a tab called resource over here, as you can see. If you select this, it will show you all the resources which is used by the application. And these are the resources, as you can see over here: database, IndexedDB, local storage, session storage, cookies, and so on. So these are some of the HTML5 components which is running in your browser. So now, say, for example, I go ahead and load these pages over here. Now you can see, if you go to the HTML5 page, as soon as we go there, we have a database created over here. So these parameter which you are looking at over here is not actually going to the server and fetching new data. It's actually the local database has been pushed from the server, and now we are just browsing in our browser itself. So this is how a database has been created. You can see over here we have a database. So this is a local database which is created inside the browser on SQLite server. So this is how simple database created. You can create an IndexedDB as well. Now we log into the application over here. We pass on username and password and log in. Now as soon as we log in, you can see over here we have a local storage created. So no cookies required. You can create a session storage or a local storage, one-time cookie or a persistent cookie. And now wherever we make a request, we can use this local storage to send the request to the server. So pretty much that is possible with this local storage and session storage. Now when we send a profile, the local storage or a session storage will play in. So this is another feature which we are leveraging in the application over here. Now we go to the index. Over here, interestingly, if you go and see a file system : then http : / whatever domain or IP address you are in, and say temporary. So it will show you a temporary file system which is in the sandbox created on your domain. So pretty much any application, say for example, Google can create a full file system on your browser for that particular domain. So this is a file system which is created locally on the system, on your browser. So this application has created a file system, and you can see a tokens of file which is created over here. So these are the features, some of these features which are added over here. Now HTML5 is not restricted just to the desktop. It is possible on the mobile device as well. So pretty much over here, as you can see, the same application created with the mobile. So we are using a browser here, and you can see over here various different APIs which we have out there. For example, you can use a jQuery mobile for creating a mobile, like a slide controls and so on. So interestingly, pretty much a mobile applications can be created. So this is a mobile application. Now you can open these applications in any browser, be it iPad or Android or so on. So pretty much you can open these applications over here, and pretty much it's going to same application is going to work with local storage and so on. Now this is interesting trend which is developing over here, which is called hybrid application. So hybrid application is essentially an application which is 20% or 15% written in native iPhone or Android, and then 75 or 85% application which is written in HTML5 container. Again, HTML5 container you can load in the native application and run. So pretty much the trend which is shifting on a mobile as well from native to hybrid. So people are using lots of different phone gap, and these architectures are out there, or libraries out there which you can use to create these kind of application. So pretty much HTML5 is out there and available, people are using it and so on. Now looking at the attack stealth and silence. So these are the top 10, maybe evolve over a period, maybe several different attack vectors would come out and possible. But I have dissected them into 3 categories. The one is XHR and tags. So CSRF with XHR and CORS bypass, jacking, HTML-driven XSS, then thick features like attacking storage, DOM, exploiting browser SQL points, injection with web messaging and workers, and then the DOM-centric attacks, which is a DOM-based XSS, offline attack, cross widgets, WebSocket issues, and interestingly, the last one is abusing with several different APIs altogether and so on. So these are the attack vectors which we are looking at. The first attack, which is CSRF with XHR and CORS, which is very interesting because the whole perception of a CSRF is going to change with XHR level 2. We'll see that why. So the target points for CSRF would be XHR level 2 calls and bypassing SOP and a CORS. So XHR is the object of HTML, is very powerful object, which is the HTML level, XHR level 2 specs has two major changes. The first change is for the request and response on HTTP, it is not just text only. So pretty much now you can pass on text, array buffer, document, blob, JSON, whatever you want to send, you can send over XHR. At the same time, you can process the response on DOM string, document, form data, blob, file, array, and so on. So pretty much, this is the first major change, which is from XHR level 1 to XHR level 2, which we have over here. Now, the second is critically important change which we have is XHR level 1 was not allowing a cross-domain call. So say, for example, if you download a page from yahoo.com, you download a JavaScript which is using AJAX or XHR, and you want to make a call to google.com, that call will not go through because XHR is not allowing that particular call. With XHR level 2, that particular restriction has been removed, and if you are following something called CORS, that particular call will go through. So HTML5 allows cross-origin calls from XHR level 2 call. What it does is it follows a cross-origin resource sharing policy where before it starts sending the actual HTTP request, it negotiate and pre-flight that whether that particular resource is allowing cross-origin or not. So server side has a control to pass on that. So there are few extra headers which are added over here, which is called access control, allow origin, and then few other headers. So these are the list of headers which are added in HTTP request and response. So request will control the origin, like we have a referrer. Now we have one more header called origin. So if you have an origin where it specifies from where I'm coming, and then based on that, the server will decide whether I want to allow this particular call to go through or not. And then the response which you get back, and browser takes decision on basis of that. So CSRF is a still threat because CSRF powered by CORS and XHR. Say, for example, if you are using a CSRF for using a script tag, or say, for example, iframe or so on, you can see the things in the bottom left where the call is going. With XHR, there is no bottom. XHR is completely still in nature. So one way CSRF with any stream, since XHR allow raw stream from XML, JSON, binary as well, so you can actually go ahead and send these CSRF on the raw stream. But more importantly, now we have another attack vector which is added, which is you can send a CSRF. What response comes back, you can read that as well. So it is like cross-site response extraction, which is also possible, provided that particular resource is allowing a cross-origin loading as well. So in our traditional CSRF, we never had the access to the incoming stream. We can fire the HTTP request, but we can't fetch the response back. So this is where XHR is leading us. And exploitation opportunities are ample. So CORS pre-flight bypass is possible with certain content type. That's another relaxation out there in the specs itself. Forcing cookie replay with credentials. So that's like you can replay the cookie if you set the with credential true. So pretty much your cookie or a login is going to go, and your HTTP request will have a clear context of your login. Information harvesting, internal crawling, stealth PowerShell is possible, and you can abuse of functionalities like upload and so on. So we'll see that as well. So for example, looking at the very simple demo, you have the web store, and a client come with a browser and log into the session. You will get a session cookie over here. Now these browser which you are using, which is HTML5 powered, so these browser can make XHR call with a JavaScript. So it will send placing an order for say, for example, buying five different shirts or so on. So it places an order. These order is actually going on the JSON, and the success will come back. So you have a JSON stream which is actually negotiating over here. Now the session is still live, and you are browsing around. So you end up on the attacker's site. Attacker will send a page which has an XHR payload there, and leveraging XHR call, it will say content type set to certain text plain to avoid the pre-flight call, and then it says with credential true. So pretty much the call which is initiated from the browser to the server over here, it will be JSON. It can be any kind of a content which is supported by XHR, and that will go through, cookie will replay, and pretty much you get CSRF over here. So this is a kind of a call will look like. As you can see, HTTP open, and we are doing a cross-origin call over here. So we are on some other domain, and we are saying, okay, I want to fire a call to yahoo.com or so on. And then next two lines where we are sending content type to text plain to bypass the pre-flight. So it's like complete open call which will go through, and with credential to true. And pretty much over here, as you can see, we can send any content. So pretty much the doors for CSRF is wide open. Now we don't have to any content, just not just the name value pair. We can pretty much do a CSRF on any type of content over here. So as soon as we click this, what is going to happen is XHR will initiate it for HTTP by without victim's consent or notice. You have a stealth HTTP request sent, and pretty much a silent exploitation will take place over here. So let me show you this demo here. So over here, we have a site which is, say, for example, a store.com. So this is a store.com site. We visit the store and we place an order, and whatever we want to do, we can do over here. So when we select a item for a buy, as you can see, it is sending a JSON request. So this is a JSON request which is going through. So this is a JSON traffic which is going over here for the request here. So this is how application is going to work. Now we log in to the application. So we log in with a credential. So we get a cookie from the server. We get this particular cookie over here. If you go over here, okay, my cookie is CID 10001. That's my cookie. And now I go to a different site, which is, say, strike.com. This is a completely separate domain altogether. And the Go is not required, but just for the demo purpose, we have just kept this. Now, as you can see over here, we can go ahead and look at the source here. So the Go function has this particular source, what I have already shown. It is making a cross-domain call, setting content type to text plain, sending true, and then sending JSON for buy request. So you have no clue. You just logged in into the application. You have no idea. You are not consent. You are just you have no clue. You are just visiting this particular site, which is a strike.com. Now, as soon as you go and click the Go button, or Go will be automatically clicked on behalf of you. So this is your XHR call, and you click on Go over here. We have a proxy on over here, so we can see what traffic going back and forth. So now when we click a Go here, you can see a cross-domain request has been initiated here. You can see a post call going to JSON services, and if you look at the content of the HTTP request over here is clearly you have initiated JSON. You can see over here the origin, which is a strike.com, and your content type is text plain over here. So pretty much this is a next generation CSRF, I would say, which is already initiated. Now, importantly, here it will work with just text plain. So if your library, your server-side library, before processing JSON, if it is compared the content type, whether it is JSON application or application/XML or so on, then you will survive. But most of these different libraries out there, as soon as they see a good JSON, they will start processing. As soon as it's a good XML, they will start processing. So some of these libraries are doing these validations. Some of these libraries are not comparing content type with the actual stream. So this is a CSRF. Now, one more interesting CSRF possibilities is in upload. So now what you can do is XHR can actually create a on-the-fly multi-part request as well. So say, for example, you have a photograph which is posted on your profile, and that particular upload form is not protected with CSRF token or so on. So what we can do over here is using XHR, we can on the fly we can craft an image file, or on the fly we can craft any other file and push it to the server, and without user's notice or consent, that particular photograph or that particular file will get uploaded on the server. So more serious exploitation possibility is a business functionalities. For example, you are placing your orders, or you are placing your PDF documents or your insurance forms or so on. So these are the places where a silent upload is possible with this particular API, or a file system API as well. So over here, for example, you have a feature on your application which allows you a bulk uploading. So you are bulkily uploading some orders, and since your cookie is on, what is going to happen is a cookie replay will allow you to upload the traffic. So you get these kind of a HTTP requests when you do an actual upload. So you will get multi-part form data, some boundary, and then you have a content type, and then you have whatever orders you want to place will go in the file. So this is how it is going to work. Now you land up on the attacker site, and attacker site will give you this this on-the-fly XHR HTTP request, which is going to do an upload on behalf of you with the multi-part. So pretty much that particular image or whatever you uploaded form or data is going to get posted on the server. So again, this upload will actually work with the silent exploitation. HTTP request will generate it. If the token or if some unique token is not there on your server side, on your upload features, then pretty much this is going to go through. So this is how code will look like. So over here, you are generating a file. So this stream can be binary as well. So this is a text file which we have created. So this is your actual file which you want to upload. So you, on the fly, create a file, give some boundary over here. Now you are creating post call over here, sending it to true, and then you are defining content type multi-part form data boundary, content length stream with credential true, and you are sending the whole content and then doing the send. If you do this, then what is going to happen is this exact request is going to be created, and a multi-part request will be sent from the browser to the cross domain. Again, over here, if your request is multi-part, you are bypassing the pre-flight. For text plain and a multi-part, no pre-flight. So let me show you a quick demo here. So over here, same form, same application. For example, we go over here and we say, okay, let me do a new order. So you are placing a new order over here, and new order has something called bulk upload here. So we say, okay, let me do a bulk upload. So bulk upload will give you the traditional form, which is doing upload file. So you pick up the file, my orders, and then you say, okay, upload the file. Now, when you see the upload file, you can see these multi-part requests, which is going and posting the file on the server over here. So this is how it is going. And now you end up onto strike.com. Over here, you can see a file has been created on the fly, and then you have the form data and so on, which we have already talked about. So then this is your form, this is your multi-part form, HTTP request, and you are crafting all this, and pretty much all looks good here, and you are sending. So now when we refresh the page, this script is going to get executed, and you can see the actual one more request has been created over here. This is the cross-domain request. So this is a CSRF request which is created, originated from strike.com CID 10001, and then the actual multi-part request over here. So pretty much new generation or new kind of a CSRF possible with HTML5. Another piece is that you can do some kind of internal scanning, and not scanning but internal crawling as well if your origin is set to star. So over here, attacker can send a page to your browser, and that will start some kind of an internal scanning. And then if we find any server which is residing on your internal network where access control allow origin is set to true or a star, that is what is going to happen is if your server has this header, then there is no pre-flight. There can be a pre-flight, but you are allowing all the content to be loaded. So in this particular case, what is going to happen is, for example, if we run this, so this is a site which is hosted on internal network, for example, and assuming that you have, if you look at the headers over here, a response header, you can see over here a response header access control allow origin is set to star here. Now you are scanning internal network, so you go to the strike.com, you receive a page, has this kind of a script here, a very simple script. We are using XHR level 2, opening a get socket, and if we get a response, then we are showing it, and if we don't get access, we say port is closed or I can't access this particular page. So for over here, for example, 54 and 55, these are the two IPs which we are trying to scan here. So we go over here, and quickly we can see over here, get URL, and okay. So 54 is closed, but as soon as 55, you can see this is the HTML content which we are extracting. So this is a CSRF, not just the CSRF HTTP request we are sending. We were able to access the actual content and fetch that back. So pretty much like you can write your internal scanner where look for all the internal IP addresses, and if we find access control true, you can start crawling the entire application and fetch all the data back to the backend server or so on. So this is actual content which we are retrieving from the server. So pretty much on top of it, you have a file API to play around with it as well. So interestingly, like file API, when we do a traditional upload, we can upload one file at a time. Now with a file API, with HTML5, you have a specs where you can actually upload the all content of directory. So say for example, if I send a page to you and say, okay, here is your contact list, please download. It's exported contact list, you download. So as soon as you click a download and select a folder, you are assuming that you are downloading, but as soon as you select a folder, you start uploading all the content of the folder from your machine to the server. So that is also possible with the file API attack vector. So how do you scan and defend? Scan and look for content type checking on server side. Tight CORS policy, don't allow all these different libraries to allow cross origin to true. Form upload, you have to be now like we never be very careful on our upload tokens. We have to be careful on our upload tokens, and defend and countermeasure secure libraries, content, CSRF protection, and strong CORS implementation. So that is the first attack vector. The second attack vector is jacking. So various different types of different jacking. It's possible where you are playing around with the HTML5 specs, or you're playing around with the HTML APIs over here. So click or a CORJacking is again a UI redressing kind of attack, where if a DOM is forced to change underlying resource on the fly, then pretty much this particular attack vector is going to go through. There is a one major change which we have in HTML5, which is very interesting. When you load the iframe, so say for example you have a page on yahoo.com and you are iframing Google into it. At that point, you can use a sandbox, and on a sandbox you can pass on the privileges. You say, okay, allow same origin, allow scripts, and so on. Now over here, for example, your site is protecting against the iframe using the frame busting code, where your JavaScript will look for what is your parent, and if your parent is not you, then you won't allow that particular application or that particular page to be loaded on the site. That you can actually bypass, because what you say is, load this twitter.com in my iframe, but don't run the script on the iframe, because now you have that particular control. So pretty much the fundamental defense which we had against the frame busting code is gone from the ClickJacking. Now coming to the CORJacking, where you are doing the cross origin resource change, which again you are using a DOM extensively. So what you are doing is you are using some kind of a DOM based XSS if it's on the application, and various different applications nowadays are running on a single DOM. So pretty much a single DOM application which you are using. So you have a DOM based XSS. So now what you can do is you can take the SWF file. For example, you have a SWF file which is a flash file which is running on your application. So an attacker, or we can find the actual place of that SWF file by document.get element by name login item 0 src, and then we can say, okay, instead of these, load these SWF file. So then you can doing the cross origin resource extraction. In this particular case, there is no policy. There is a content security policy. If the content security policy is not placed, then you can pretty much your page will load these this particular SWF file and load it. So over here, for example, you have a little SWF file over here called login, and then you are changing that login to something else on the fly. So this is a kind of a payload which will look like, and pretty much over here, for example, to bypass the single quote or double quote, you can do a double eval trick, where your first eval will actually convert your string back into the payload, and then the second eval will actually execute it. So over here, let me show you the quick demo again here. So assuming that you have a kind of a bank here, a foo bank over here, and you are logging in. Now these particular component is actually SWF file or a flash, which you are looking at over here. So we have a login.swf file here, and over here it is doing some kind of a eval. So it's a DOM-based cross-site scripting, which we have, or access to a DOM-based cross-site scripting. So instead of this, we say alert 1, then it's going to pop up. So we have the clear case of DOM-based XSS over here. Now we can go ahead and say alert high, which is not going to work because it will not like these %22. So then we have to bypass this as well, since we are passing through this over here. Now interestingly, you can see this is a completely separate domain, 100.200, a same login component residing over here. There is just the one difference. You have a little red line here. So this is a cross domain. This SWF file is on this domain. Your target bank is foo bank over here. Now you can actually pass on the payload over here. So we can take these login SWF file, and if we want to go back to our DOM, So this is kind of a payload where we are saying, okay, take these SWF file and change it, and to bypass this single quote, convert it into actual eval. So then we can do a double eval on the stream, and that is going to actually change the SWF file on the fly. So now we can take this payload over here and this whole payload over here, and now we can pass it over here. Okay, and you can see the actual page or actual SWF file is component. So you are on the target domain, but the underlying SWF file is actually changed. So again, scan for this, only difference now we are left with is X frame options. So you have to have X frame options to bypass or protect your application against ClickJacking over here. The third attack is XSS, the traditional XSS, but what we have is with HTML5, we have several different new tags and attributes and events like buttons, commands, form, attributes, and so on. So there are tons of different XSS opportunities and possibility over here. For example, a video tag, you can do on error on source, or a video on error, you can inject XSS. You can use input select text area keygen. These are the areas where you get a lot of reflections back, right? So you can use autofocus, on focus attributes or events for these as well. There are a lot of different permutations, a lot of different variants over here. You can find a very nice cheat sheet on html5sec.org where HTML5 based XSS cheat sheet is kept. But this is definitely an interesting attack vector to bypass the existing blacklist or a whitelist, because you have a blacklist where you are allowing certain tags, and these are the new tags which is possible to cause XSS. Okay. The fourth one is interesting, which is called the web storage. So you have a web storage where your attack vector is either on a storage or either on a file system here. So what we have with the web storage is HTML5 supports a storage API, and a storage API has two types. One is called local storage, and another is called session storage. And what we have is, say for example, you want to set a local storage, you can pass on, say, local storage set item and then push the variable. So you can pass on a name value pair into the local storage. You can store a JSON as well, or whatever you want to store, you can pretty much store on this particular variable. So then what we can do is, when we have an XSS possible available, you can do a blind enumeration of these variables, local storage. And if you find local storage, you can extract these local storage. So if you run these loop where you look for a local storage and then extract all these different variables, then pretty much you get access to local storage. So let me show this over here. So here we are logging in onto the site, and when we log in, we will run these little script which is going to do extraction here, and we use XHR to pass the content back to the server where we are listening using this particular script called for node.js. So we are running node.js as our listener, like which we have for the beef or so on, and we have access control allow origin set to start. So pretty much we have a two-way tunnel established over here. Now we can go ahead and run the script here. We are running the script and listening for this, and this is our actual IP address here. Now we go back and take this script as our right now payload, and if we just want to show this over here, so we go back, open the developer toolbar and run this. We just forgot the two variables on the top, so let me take the whole script here. Okay, and pretty much you can post this and run, so you can extract these particular local storage variable from the DOM. Now pretty much you have a point of XSS somewhere here on the application. For example, this search page has XSS. So over here we go ahead and input our actual payload. Here is our listener which is listening, and now we put a call here, script src, where we want to, and as soon as we do this, you can see the actual variable is extracted from the DOM and shipped back. So this is possible. Another interesting one is a file system. As I said, you can create, a domain can create the whole file system within the browser with these APIs, which are available for different browsers as well. and it is a sandbox. When you create a file system, it actually create a file system on SQLite on your local machine. So you can create a file system with this particular call, a temporary create a file size over here, and then you can start using a file system. So when you create these file, actual file is going to get created, a file system local host, and then you have the content on the file. So over here, for example, we log in again to the application. This application is creating some kind of a file system. So we have a login. After logging in, if you look at the source code, JavaScript code here. So JavaScript code over here is creating a file system called fs.js, and it is actually creating few files. So one file is this particular file. So it is creating a file, and now we go over here. Instead of a view source, we say, show me a file system. So the file system, then http:// temporary storage. The file system over here, we say temporary. It can be permanent as well. You can create a permanent file system on the browser. So you say temporary, and you can see all these different files which are created. And your target is, say, for example, token file, which you want to grab. So over here, you go to the blog, and on the blog, over here, you can take these as a payload. So as a payload, what we are doing is we are trying to extract these token files from the file system using JavaScript. So, and then we just alert the box over here. So now we go ahead and take the source and put it in our XSS, a persistent XSS or reflected XSS code, and say blog. So now whoever visits the blog, that particular file is actually going to get extracted from the system. So pretty much a local storage is you have over here, which allows you to extract these kind of a content. So local storage is another interesting area, and on top of it, you have some kind of a DOM storage as well. So these application written in HTML5 has a single DOM, and single DOM has various different global variables which are created, which can be used over here. So again, you can loop through the global variables and extract global variables from the DOM. And many times you go around and look for these global variables. You find a lot of interesting information on global variables like email, your OAuth tokens, and so on over here. So you can extract all these over here. Say, for example, on these application, okay. So let's just skip through. So this global variable, so you have a local storage extraction, you have file system extraction, and then you can actually extract local storage from the DOM with the DOM-based XSS. So scan and look for scanning storage, defense and countermeasure. Do not store sensitive information on local storage, sensitive storage, file system, or your DOM storage. And XSS protection, be it DOM-based, reflected, or persistent. The fifth vector is SQL and blind enumeration, where we are trying to attack webSQL or IndexedDB files. So webSQL is another specification which we have within HTML5, which has two important calls called open database and execute SQL. So you can actually create a small database within your application domain and extract and use it. So if you open a developer tools, then you can see the actual tables which are created on the database, which you can use. And say, for example, if someone wants to exploit these particular situation, then what we need is a database object, we need a table structure created in SQLite, and then we need a user table over here. So pretty much these loop, if you run these loop, what it is doing is, it is on your DOM, it is trying to identify a database object. If it finds database object, then the database is SQLite. So what it is doing is, it is going and fetching the table name for SQLite database, and then it is actually running the SQL queries. So pretty much you don't need any knowledge. Like it's a completely blind SQL injection or an enumeration which you are doing on your browser side. So we are still dealing with SQL injections on the server side. Now we have SQL injections on the client side or a browser side using XSS. So it's like a combination of XSS and SQL which we are looking at over here. So this is how you can do a blind enumeration. And if you do this, then pretty much you can extract the entire database from the server. So over here, for example, if we Okay, so over here, for example, we have the same site here, and now we are going and looking at the view page source here. So as you can see, the database has been created on this particular page, and now we go ahead and identify a place over here. So we inspect elements, and we get a console. We take these loop over here and run these loop, which is a blind enumeration component. So we take this and run here. We can see the items tables which we actually extract, the database object, the table, and the user table is item. And pretty much we can use this to enumerate over here. And even we can do a typical injection over here, like a 1 or 1 equal to 1. Instead of a 1 entry, we get the entire entry back. So pretty much it's possible to have these attack vectors as well. Okay. And similarly now, webSQL is also replaced by IndexedDB. So you have something called IndexedDB, like which you have for your webSQL, and then you use open transaction and create object for your IndexedDB. So there's a fifth. The sixth attack vector is leveraging web messaging and web workers. So these are the completely new feature which you have in HTML5, and pretty much where you are using messaging, you are using JavaScript and using parser threads for this particular vector. So what is web messaging? So HTML5 is having a new interface for a communication, and it is using something called post message. Say for example, your application wants to talk, two iframes want to talk with one another. At this point, you have to tunnel through the server. Now that is not the case actually. With HTML5, you can allow two different components running within the browser. If you want to talk from your front page to back-end web worker, or you want to talk from front page to another page which is on the same iframe on the same DOM, then you can use this web messaging protocol. So post message, if it's set to star, that means any origin you can start talking with. And if it is restricted to particular origin, then that is the only origin you can talk with. The problem with the web messaging and a web worker is a DOM-based XSS, because the traffic which is coming back is not validated. So pretty much if you are doing inner HTML document.write or eval of these calls, then it is going to cause a DOM-based XSS over here. So one of the important check which we should make is looking for the origin here and making sure that if we are talking with the Yahoo, then its origin is Yahoo, then and then allow these post messaging or a tunnel of messaging in between. And same with the web worker. So web worker is a spec in HTML5 which allows you to run threads in the background. So what you can do is, through a JavaScript, you can define a worker thread and then say, okay, run task.js in the backend. Say for example, I'm running a task at the backend which is keep on checking my emails every 5 minutes, and then as soon as I have an email, it will pop up on the screen. So these kind of a task is possible, and then your worker thread can talk with your front thread using worker.postMessage as such. So what we have in a web worker is, web worker doesn't have the access to the parent DOM. It's like the completely separate isolated thread. So it can't access the DOM, but other than that, it has all different accesses like XHR, location, navigation, JavaScript, regular expression, array, JSON, and so on. And a security issues, definitely we have some security issues. One is an in-domain and a CORS request is possible. It can cause a DOS, which was fixed in some of these browsers. And message validation, if DOM-based access, it can cause actual DOM-based XSS. So over here, for example, on this particular script, we have created something called web worker, which is a message.js, which is checking the mails at the back end. And as soon as a new mail comes or a last message, it will take the new data and putting into a document.get element by ID result on inner HTML. As you can see, it's an inner HTML call. So pretty much when you have these inner HTML call, it can cause a DOM-based, or it can cause the XSS over here. So now if we go back here, and let me show this. So this is a little widget, which is a messaging widget, which we are looking at. And messaging widget has something called a read last message here. Now as you can click on the read last message over here, you get XSS, because that message is coming from a third party, and pretty much you are just loading in inner HTML. So over here, as you can see, this is your web worker thread, a read and a stop thread, which we have over here. And you are running a new worker and a message thread here, and then loading these particular value into inner HTML. So pretty much very interesting new features which we have for both web workers and web messaging. But again, it's all secure coding practices which is required when you're using JavaScript over here. So what we have is a possible to cause XSS running script, passing hidden payloads. Also, web workers can help in embedding silent running files. Can be a tool payload. This particular backend thread altogether can be used by botnet or worm or so on to keep eye on something which is running on the backend thread over here. So this is possible. Again, you can, interestingly, in the spec, they have written that you can't load a cross-domain JavaScript on your web worker, but then in the web worker, you can use something called import script and then load a third-party stream or third-party JavaScript into your DOM. So that's interesting spec over here for web worker. So scan and defend, JavaScript scanning, messaging and worker implementation, and defense and countermeasure, same origin listening. This is a very important criteria when you're implementing cross-site post messaging in your application. The seventh attack vector is again DOM-based XSS with powered by HTML5, where again you are leveraging JavaScript, messaging, and DOM event over here. DOM is pretty much, we are right now on a DOM 4 spec, so you can see some kind of interesting specifications out there, like you can use XPATH within your DOM as well. So you can have like kind of a XPATH injection in your DOM or so on. So this is a kind of a heavy DOM specs which we have. And DOM-based XSS, it is a sleeping giant. The root cause of DOM is already loaded. Application is a single page and DOM. This is a kind of a architecture which we are looking at. Is HTML5 based application will run in a single DOM. So when you load the page on a slash, that DOM is not going to change. Only DOM will keep on changing. The whole refreshing and reloading of DOM will not take place. Just the partial DOM changes will work. So essentially what is going to happen is when you have a DOM-based XSS, then that DOM-based XSS will remain throughout the application lifecycle. So information is coming from untrusted sources. You have a JSON padding usage, web workers, and callbacks. So AJAX with HTML5 DOM, AJAX function would be making a backend call. Backend would be returning JSON, and then in some libraries, their content type would not be validated, and then it will actually go ahead and process these particular calls. So this is a very simple DOM-based XSS over here, as you can see. There is a little RSS feed reader, and this feed reader is fetching the feeds from the server and then showing the feeds. Now, if you look at the line of code which is being executed when you run these component, so you can use over here, you can go ahead and this is your RSS feed reader, completely in HTML and JS. And now we go ahead and start over here. DOM tracer, which is just show you the line of code which is executed on the application when you fire any particular event over here. So we fire, say, get me a trade news over here. So at that point, you will have these lines which are being executed. And when you go through the source code in a static fashion, you will find that there is no validation or there is a opportunity for DOM-based XSS. It is making a GET call, finding the actual stream, and then posting it on the server over here. Okay, so this is how you get the inner HTML, and at that point you will cause the actual XSS over here. So we get this stream, and this stream will actually go ahead and do the alert. So as soon as we click that particular object, it's going to cause DOM-based XSS. So DOM-based XSS, you can do DOM calls, evals, look for the static analysis on the DOM-based XSS. The eighth one is third-party or offline HTML widgets. So pretty much you have, interestingly, you can have the cache poisoning, the browser-side cache poisoning possible with HTML5. There is a tag called manifest through which the cache being injected in your browser. HTML5 driven widgets, if they are sharing the same document object model or a DOM, then pretty much a cross widget sharing or a cross widget would be possible, and that is going to cause another security concern as such. And then we have a WebSocket, which is again another interesting component which we have in HTML5 browser, by which you can create a duplex channel and so on. I think the third talk on that same track is completely on a WebSocket, where the Qualys folks are going to show that as well. So there are a lot of different stuff which can happen with this. HTML5 allows WebSocket APIs, full duplex TCP channel, possible threads, backdoor and browser shell, quick port scanning, botnet and malware leverage. Sniffer can be created, like kind of a WebSocket driven sniffer you can create as well, and you can do internal scanning. On top of it, we have different types of protocols, schemas, and API attacks. So for example, you can register your own protocol, like we have a mail to in a browser. Now we can register mail to protocol, and it is not actually opening the browser mail to, but it is opening and sending your email ID or so on onto a foo.com or so on. So these are the different registrations, different protocols are out there. So drag and drop API, file APIs, and so on. There are tons of different APIs out there. Now finally, let me show one last attack vector here. So one of the problem, or one of the thing which we have is when we access, say for example, this particular application, then if there is a search form, or if there is a persistent XSS, when you do this, your XSS will be there, your payload will be there till you are on the page. But what you can do with HTML5 is you can create a sticky XSS. You can say, like, even you move on to other parts of the same domain, the XSS will remain still live. So pretty much you can use an API called push state. This API will change the address bar altogether as well. So it's completely remains stealth over here. So say for example, we have XSS over here on this particular place. And now we go ahead and look at these payload, or this mechanism, where we are setting the same URL as our URL. And this is our listener, which is listening the traffic which is coming back from the server over here. And if you look at the payload here, what we are doing over here is we are sending the post message, and this is the interesting iframe. So what we are doing is we are injecting an iframe through the XSS and loading the same page on the XSS. So in between, we have our JavaScript or code would be running. So on the sandbox, we are saying allow same origin, allow form, allow script, and since we are on the same origin, we get access to the DOM as well. So we get that, and pretty much then we are listening for all the inputs which user is making, and we are using push state. This is a new HTML5 API by which you can actually change the address bar as well. So you can change the address bar. So say for example, if you are on yahoo.com and you are actually, as soon as you load the google.com on the iframe, you can still on address bar, you can see yahoo.com or so, your target domain. So you have that over here, and then you are listening and sending the message back to port 8080. So now let me pass on these payload here. So we start the node server, which is listening on 8080, and then we say script src port 8080. And now, as you can see, we are listening. The guy is actually moving around on the same domain, and our script is sitting in between. So now, if say for example he goes to login, you can see the page, the address bar will change, and as soon as he say foo or whatever password he enters, we are listening for inputs which are being made over here. So we say foo, we can see the foo over here, and foo bar over here. So pretty much HTML5 has components, if they are not securely coded, then pretty much can cause different vectors. These are some of the interesting resources and references. HTML5 rocks.com, a solid HTML5 based knowledge you can gain. OWASP cheat sheet, which we are running as well on the OWASP. You can find the HTML5 cheat sheet where all these different attack vectors and protections are mentioned. HTML5sec.org, a quick cheat sheet. HTML5security.org, which is keeping a good set of resources on there. And blog of kotoviz.net. He's doing some interesting work on HTML5 as well. So these are some of the references. So that's pretty much it from my side. Thank you very much for listening me patiently. And if we have time, sorry, we don't have time for questions, but I will be around if you have any questions. Thank you very much.